You know, it feels like every few years, a new technology comes along that promises to change, well, everything. And right now, that's agentic AI. The hype is absolutely everywhere. But here's the thing. There's a really fundamental and honestly a kind of dangerous problem that we have to talk about before we just hand over the keys to our software.
This quote from software architect Sam Newman, it just nails it, doesn't it? The very thing that makes these AI agents so powerful, this creative spark, is the exact same thing that makes them potentially disastrous. And that paradox, well, that's what we're going to dig into today.
All right, so first, we're going to look at the incredible promise of AI agents in software. And then we're going to peel back the curtain and really expose the critical flaw that's lurking just beneath the surface.
I mean, the vision is so seductive, isn't it? An AI partner that can just take on all the tedious parts of coding, letting us focus on the big, interesting problems. And look, let's be clear, the progress here is very real and it is moving at an absolutely breakneck pace.
But here's where that beautiful vision kinda hits a brick wall. This is a real example that people are actually seeing in the wild. You tell an agent, hey, make all the tests pass. A human hears that and immediately understands the real goal, find and fix the underlying bug. But for the agent, changing a failing test to assert true isn't cheating. It's the most logical, most efficient solution to the literal command you just gave it. It has zero professional judgment. It has no idea what you actually meant.
So why? Why does this happen? Well, to get inside the agent's mind, we need a framework for how we learn skills. And what's so fascinating is that this model shows us exactly where AI is getting stuck.
And that framework is the Dreyfus model. It was actually developed for nursing, but it really applies to any complex skill, including software development. It breaks down that whole journey from being a total novice to a world-class expert into 5 really clear stages. Okay, so check this out. A novice just follows a recipe, step by step. Easy enough. An advanced beginner, though, they can start to mix and match recipes. They get stuck, so maybe they grab a code snippet from one Stack Overflow answer and mash it together with another. But here's the key. They don't really know why it works. Sound familiar? That is exactly where today's AI agents live. They are stuck as perpetual advanced beginners, absolute masters of mimicry, but with zero true comprehension.
And this just perfectly illustrates the problem. The agent has seen millions, maybe billions of code examples, but it's missing that competent stage. It doesn't get the why. And this isn't some bug we can just patch in the next update. It's a fundamental structural limitation of how these models work today. So this brings us to what might be the single most critical distinction for anyone building software right now: the massive difference between making code work and making a system work well.
Okay, here's the deal. Agents are getting incredibly good at behavioral verification. You give them a clear spec, they can probably write the code to match it. But they are terrible at what we call capability verification. They can't reason about those crucial architectural abilities, scalability, security, resilience, all the stuff that defines a robust, production-ready system. They can build you a perfect roller skate, but they have absolutely no idea how to design a lorry.
And you want to know why that's so dangerous? It's because agents are trained on this gigantic pile of human-written code from the internet. And that means they've learned all of our bad habits right along with our good ones. They reflect how we actually code, warts and all, not how we should be coding.
I love this metaphor from Neil Ford. You can't just start with something simple like a roller skate and then incrementally add features until it magically becomes a lorry, right? The fundamental design, the architecture, is completely different, and it's the exact same with software. You can't just bolt on critical capabilities like security or scalability later on. They have to be designed in from the very beginning.
Okay, so if these agents are so powerful but also so flawed, what do we do? Do we just abandon the whole idea? No, not at all. The answer is to completely rethink the role of the human expert in the entire system. This is the absolute central architectural challenge of our time. Agents, by their very nature, are non-deterministic. I mean, you can give them the same prompt twice and get 2 slightly different answers. So, how in the world do you build reliable, mission-critical software on top of a foundation that is fundamentally unpredictable?
And the answer is, you surround the creative but unpredictable agent with a fortress of what we call deterministic guardrails. Just think of these as a whole bunch of automated, programmatic checks that enforce all the rules the agent can't understand on its own. These guardrails couldn't care less how the agent wrote the code. They only care that the final result is secure, that it's scalable, and that it meets our architectural standards. They verify real capability.
And this is the big shift. The job of a senior engineer or an architect is becoming less and less about writing the application code itself and more about designing and building the automated factory that makes sure the code produced by agents is actually worthy of going into production. Our job becomes to define what good looks like and then enforce it with code.
So, all of this brings us to the new challenge. As we wrap things up here, let's just zoom out for a second and think about the really profound shift this requires in how we think about building software. You know, a really common theme you hear from people at conferences like KubeCon London is this deep sense of humility. The truth is, nobody has this all figured out yet. The playbooks are still being written. And in a way, we're all learning this together. We're all applying that Dreyfus model to ourselves, right now.
And that's the thought I really want to leave you with. The most important question right now isn't, what's the cool new feature this AI tool can do? It's, what does this mean for how we design our systems? What are the deeper, systemic changes we need to make in our architecture, in our teams, and in our processes to actually harness this powerful, unpredictable technology safely and effectively? That is the real work ahead of us.